Imagine a machine that can breathe for the planet, a machine that acts like a vacuum cleaner for the sky, sucking up the invisible poison that is heating our world. Right now, as you watch this, the Earth is choking on record high levels of carbon dioxide. According to NASA, 2024 and 2025 have already shattered global temperature records, making the climate crisis an immediate emergency. We have spent decades trying to stop CO2 from going into the atmosphere. But what if we could take it back? What if we could literally undo our mistakes? This is the story of direct air capture, or DAC. It is a multi-billion-dollar bet on a technology that sounds like science fiction. It involves massive, building-sized fans designed to pull CO2 straight out of the thin air. But can these giant fans really save us? Or are they just an expensive distraction? For centuries, nature had a perfect system. Trees and oceans absorbed carbon, keeping our climate in balance. But since the Industrial Revolution, the result, humans have dumped over 1.5 trillion tons of CO2 into the atmosphere, a planet that is warming faster than life can adapt. Traditional methods like planting trees are great. We need something faster. But they take decades to grow and require massive amounts of land. We need something industrial. That is where companies like Climeworks and carbon engineering come in. They aren't planting seeds. They are building steel giants. These machines use powerful fans to pull ambient air through a filter. Inside these filters, a chemical reaction takes place. The CO2 molecules stick to the surface while the rest of the earth and nitrogen and oxygen passes right through. Once the filter is full, it is heated up to release the concentrated CO2. But here is the suspenseful part. Once you have captured this gas, where do you put it? You can't just let it leak back out. In remote icy landscapes of Iceland, a facility named Mammoth is providing an answer. It is currently the world's largest DAC plant, launched by Climeworks in mid-2024. They take the captured CO2, mix it with water, and pump it deep underground into basalt rock formations through a process called mineralization. The carbon reacts with the rock and turns into solid stone within just 2 years. It becomes a permanent part of the Earth's crust. This isn't just storage, it is a geological delete button for pollution. However, the scale of the challenge is staggering. To keep global warming below the critical 1.5-degree limit, the International Energy Agency, IEA, says we need to be capturing about 60 million tons of CO2 every year by 2030. Currently, we are capturing only a tiny fraction of that. Why? Because it is incredibly expensive. Capturing 1 ton of CO2 can cost anywhere from $600 to $1,000. To put that in perspective, we emit over 37 billion tons every year. The math simply doesn't add up yet. We are spending millions to fix a problem that costs trillions. This has led to a fierce debate among scientists and world leaders. Is this technology a miracle, or is it a moral hazard? Some critics, including prominent climate scientists cited by the BBC and the New York Times, worry that DAC gives big oil companies an excuse to keep burning fossil fuels. If we have a machine that cleans the air, why stop using coal or gas? This is the cliffhanger humanity is facing. Major players like Occidental Petroleum are already investing heavily in DAC. They claim they can use the captured carbon to squeeze more oil out of old wells, a process called enhanced oil recovery. It feels like a contradiction, using a climate-saving machine to produce more of the fuel that caused the problem in the first place. Despite the controversy, the momentum is unstoppable. The US government has recently committed billions of dollars to build DAC hubs across the country. Tech giants like Microsoft, Google, and Shopify are buying carbon removal credits to offset their own footprints. They are betting that, just like solar power and lithium batteries, the cost of DAC will plummet as the technology matures. We are in a race against time. Every year we wait, the carbon debt grows. These giant fans are attempts to pay back that debt. They represent human ingenuity at its peak, the ability to engineer our way out of a disaster we engineered ourselves. As we look toward 2025 and beyond, the question isn't just whether the technology works. It does. The real question is, can we build it fast enough? And more importantly, will we use it to actually heal the planet, or just to delay the inevitable? We're standing at a crossroads in human history. We have the tools to vacuum the sky. We have the power to turn gas into stone. But technology alone is never the full answer. It requires the will to change how we live. So, what do you think? Are these multi-billion-dollar fans the ultimate shield for our planet? Or are we just trying to put a bandage on a wound that is too deep to heal? The air we breathe tomorrow depends on the choices we make today. Let us know your thoughts in the comments below.